In today's lesson, we are going to be looking at solving word problems with equations. So before we get into actually looking at some word problems, just some tips or things to think about. The first one is highlight, and want to repeat like highlight, highlight, highlight. Right? Because we're dealing with word problems, all the information is going to be within the question, within the scenario, within the information given. So it's going to be very important to highlight so we understand what's being given to us or what we might have to use. And there's a couple things we want to make sure we highlight, and this is kind of going hand in hand with the practice that we're doing at the beginning of class. Right? We want to highlight what is the question. Right? We want to highlight any numbers. We want to highlight alert words: if, but, would, should, then. So these are things that are words that might kind of give us hints as to what might be happening or things that we might want to pay attention to. We also want to look at what the variables, we got what in there twice. We want to think about what the variables represent. So in our equation, we have an unknown, right? We have variables. When we're solving equations, we had x. So we want to know, what do the variables represent in this scenario? What does x represent? Is it money? Is it time? Is it number of people? Whatever the case may be. And the reason we want to do that and know what the variables represent is that because chances are we're probably going to have to substitute a value into a variable. So we're going to have to replace a variable with a value. And if we know what those values or variables represent, it's going to be easier to substitute. So let's take a look at the first one. So a machine salesperson earns a base salary of $40,000 plus a commission of $300 for every machine they sell. The equation to represent their earning is E equals 40,000 plus 300 M in terms of machines sold M. So we're going to go through and highlight some important things. I'm going to highlight the numbers first. So a base salary of 40,000, commission of $300. We have an equation. Those are all of our numbers. Any alert words? Not really any alert words. We do want to know the question. The question right now for A is, if the salesperson sells 12 machines, how much did they earn during the year? So we have another number to highlight. So I'm going to go back, highlight 12, because we have 12 machines. We have an if, right? So that's kind of standing out to us. So that's telling us that something's going to be happening, right? So a specific scenario. And because it's a word, it's an equation, we want to also know, what do our values represent? And we do know, or we are told, that M is machines sold. So I know M is my M variable, or machines sold. And I also am told earnings, right? So E would be my earnings in this case. So for A, I'm going to start off with my equation. Because I'm given it, chances are I'm going to have to use it in some case. Now the next step we kind of said was, we're probably going to have to replace something or replace one of our variables, right? I have two unknowns, E and M. I can't solve an equation for one or the other because I would still have a missing piece, right? So this is where substituting a value in becomes necessary. So what am I going to replace? Well, the question asks, how much did they earn? So that means I'm looking for that E value. Because I'm looking for that E value, I should then have a number that I can replace this M value with. And if I look at my question, I do, because it says they sold 12 machines. So that means, let me move this down. For this specific question, I'm told that M is equal to 12. So I can replace M with 12. So plus 300 times 12. And now I can solve this equation. I don't actually have to solve anything. It's just going to be a calculation. right? I don't have to rearrange anything. I don't have to worry about moving anything to a side because E is already by itself. So 300 times 12 plus 40,000 gives me 43,600. So that means, therefore, they would make $43,600. For B, it's going to be the same idea. I do see an alert word. I have if. I do see a number, 1 million. And the question says, how many machines would they sell? We could say like if they earn, right? Because that's still, it's all one kind of one long sentence. So if a salesperson sets a goal to earn $1 million, how many machines would they sell? So I'm looking for M. I am going to use that same equation. E equals 40,000 plus 300 M. I need to solve for something. I need to solve for either M or E. Well, the question tells me a goal to earn $1 million. So that tells me that I'm looking to solve this equation for when E equals 1 million. So I can replace E with 1 million. And when I do that, I only have one variable left, which is M, and I can now solve this equation for M. And it's going to be a two-step equation. I'm going to move my separate term first, or the non-variable term. So I'm going to subtract 40,000, subtract 40,000. One side cancels out. I'm left with 960,000 equals 300M. To cancel out the 300, I'm going to divide by 300 to both sides. One side cancels out. And I'm left with 3,200 equals M. So that tells me, therefore, they need to sell 3,200 machines. So these are really going to be our two scenarios when we're dealing with these types of word problems. For our purposes, this is as complicated as it's probably going to get for the word scenarios. We've looked at some area and perimeter ones, and we'll look at one later. But for word problems, these are our two scenarios. We plug a value in and we calculate, or we plug a value in and we rearrange and solve. Let's take a look at the next one. The price of a wedding venue is modeled as C equals 200 plus 30p. So not too much here. We do have numbers because we do have an equation. There's not much else given to us. C equals 200 or 2000 plus 30p. If we look at A, this will give us a little bit more. It says if, so that's important. So this is telling us that something's going to happen. We do have a number of 150 people. And it says if 150 people attend the wedding, how much would it cost? So we're looking for how much would it cost. That's the question. We need to figure out a cost. Now there is some additional information here. Right? Even though it doesn't really tell us this in the question, I'm kind of given two things or two pieces of information. One, 150 people, and another one, I'm looking for the cost. I have two variables in my equation, C and P. So if I had to guess, I would say that C probably equals the cost, and P probably equals people. Right, so even though the question didn't tell me that, I was able to kind of get that from what information the question was asking. Right? So if you're not given information on what the variables are, look in the question, look in the scenario itself, and that might help. So I'm going to write out my equation. C equals 2000 plus 30p. All right, if I want to do anything with this equation, I need to replace one of those variables. I need to either plug something in for cost or for number of people. Well, the question does give me a number, 150, and that represents people. So that means P equals 150. Because I know that that variable equals 150 for this scenario, let's plug it in. C equals 2000 plus 30 times 150. Oh, look, the only variable I'm left with is C, which is cost. That's what I'm looking for. I can actually solve this equation now. I don't need to rearrange anything. So I just need to calculate 30 times 150 plus 2000, and I get the cost equals 6,500. So therefore, for 150 people, it would cost $6,500. For B, we have a little bit more of a question, so another question, so let's kind of go through and highlight some things. A couple has a budget of $15,000. Okay, that's a number. How many people can they invite to the wedding? That's the question. All right, so in this question, I'm looking for number of people. How many people? And that usually indicates which variable I'm trying to solve for. Because if my equation is C equals 2000 plus 30p, if the question is asking for what is p, chances are this question should give me enough information to replace the other variable. So there should be enough information here to replace c, and it does. There is a cost. The cost has to be 15,000. It can't be any more. Right? So that tells me that c has to be 15,000. So 15,000 equals 2,000 plus 30p. Now I have a two-step equation. I can solve for p. I'm going to remove the non-variable term, so minus 2,000 from both sides. One side cancels out. 13,000 equals 30p. Divide both sides by 30. And we're left with $43 or 433.3 repeating is P. So therefore, they can invite 433 people. Now in this scenario, because I have a decimal, I can't say 433.3 people because I can't invite a third of a person. I also can't round up. One, because the decimal is not 5, and two, if I round it up, technically that would put me over the budget that I have. Right? So for a budget of $15,000, it's exactly 43 or 433.3 people. If I round it up, that's going to be more than 15,000. So in this case, I need to round down. So 433 people is the maximum they could invite with this budget. Example 3, Martha owns a pizza business. A plain pizza costs $10 and includes sauce and cheese. Regular toppings are $2 each, and premium toppings are $3 each. This one's a little bit different. We're not given an equation. We want to write an algebraic equation to represent the cost. So again, let's go through and highlight. We have $10, $2, and $3. Those are our values, our numbers. We do have a question that says write an algebraic equation to represent the cost of a pizza. So we have to come up with an equation. I might highlight as well, regular toppings are $2, plain pizza is 10, and premium toppings are $3, just so we know what the variables represent, or just what the numbers represent. So in this case, I need to come up with a cost for the pizza. So I'm going to start off my equation with C. So what does the pizza cost? What would it cost? Well, we know a plain pizza, right? If I was to get nothing on it, it costs $10. So at minimum, it's going to be $10. Now I can add toppings. I can add regular toppings and premium toppings. But right now we don't know how many of each we want to add. So if we don't know how many we're going to have, or if we don't know what a number is going to be, we can replace that with a variable. So in this case, I can say that R will equal number of regular toppings. So I can use R to represent the number of regular toppings because, again, I don't know how many I'm going to have. I have premium toppings, so I can use P to represent the number of premium toppings. Because they're two different costs, so they should have two different variables to represent them. Now, how am I going to put that in the equation? Well, I know it's going to be $10, and then I'm going to add an additional cost for the toppings that I get. So in this case, for a regular topping, it's going to be $2 times the number of toppings, which we don't know. So in this case, we use R. So 10 plus 2R. I also have to add my premium toppings, which are $3 each. So in this case, it'd be 3 times P. 3 times however many premium toppings I get. And this will be my equation to represent the cost of a pizza. And I can also, I guess, put that C equals cost. Just so, again, we know what every variable represents. So, again, same question, but now Eustace does not order any premium toppings and buys an $18 pizza. How many toppings did he order? Well, we can highlight 18. Right? We can also highlight the question, how many toppings did he order? And we might want to add, does not order any premium toppings. Right? So that's some additional information that we might need. I'm going to rewrite out the equation that we had before. C equals 10 plus 2R plus 3P, because chances are we are going to need that equation. Now, I have 3 variables in this case. 3 variables. I need only one, right? If I'm trying to solve, I need to have one variable to solve for, right, to get a value. So I have to look to the question to see, okay, what information is there that I can use to replace a variable? Well, he does not order any premium toppings. So that tells me that P has to equal 0. I'm also told the cost because I'm told that it's an $18 pizza. So I know that C equals 18. So now I can plug that information in. So instead of C, I can write 18. So 18 equals 10 plus 2R plus 3 times 0. Oh, now I only have one variable left. So now I can go through and solve. 18 equals 10 plus 2R. The 3 times 0 is 0, so that just disappears. Oh, I have a 2-step equation. Cancel out the non-variable term, do it to both sides. I'm left with 8 is equal to 2R. Divide both sides by 2. One side cancels out, and I'm left with 4 is equal to R. So that means, therefore, he orders 4 toppings. So in this case, we had to plug in 2 variables, and that allowed us to solve the equation. For C, Xavier's parents gave him $30 to order pizza. He wants 3 premium toppings. How many regular toppings could he then add? So the question is asking how many regular toppings could he add? We have some numbers, 3 premium, $30. Right, we'll highlight to order a pizza and 3 premium toppings because that will give us some additional information. I'm going to start off with what I know. C equals 10 plus 2r plus 3p. That's our equation. We want to solve for the number of regular toppings, so I should be solving for r, right? Because r represents the number of regular toppings. That means we have to fill in values for c and p. Well, go back to our question. The cost can't be more than $30, so c has to equal 30. P equals 3 because he says he wants 3 premium toppings. So let's replace our variables with those values. So instead of c, I'm going to write 30 equals 10 plus 2r plus 3 times 3. So 30 equals 10 plus 2r plus 9. Or I'm going to do some, just to save some room because I know it's going to be kind of jumbled at the bottom. I can add the 9 and the 10 and make it 19. So 19 plus 2r equals the 30. Now I'm back down to a two-step equation. Let's minus 30. That's minus 19, the non-variable term. Minus 19 from both sides. One side cancels out. 30 minus 19 is 11, so 11 equals 2r. Divide both sides by 2. One side cancels out. I end up with 5.5 equals r. So therefore, he can order, or add, we'll keep it consistent. Therefore, he can add, assuming he can only add 5 toppings, or whole toppings, we'll say 5 toppings. Right, he can only add 5 toppings, right? Because it's 5.5, you can't round that up to 6 because 6 toppings would make it more than the $30. So even though technically, yes, you would round up, in our scenario, you can't round up because that would put you over your limit, so you have to round down to 5. Any other question, if you're just looking to answer or looking to find the value, you could leave it as 5.5 or round up, but given the scenario, you can't. You have to leave it at 5. The last question, Pauline builds a fence around her garden, which is shaped like a parallelogram as shown below. Pauline uses 100 meters of fencing along the perimeter of the garden. Find the dimensions of her garden. So let's highlight. I'm going to go through, highlight 100 meters. I'm going to highlight the numbers on my diagram. Let me just put those back out in black just in case you couldn't read it. X plus 200, X minus 10. I'm going to go through, highlight the question, find the dimensions of her garden. There doesn't seem to be any alert words. No should, would, if, then, but. However, there are some kind of keywords I do want to highlight. Perimeter. Because that will help me solve this question. Right? If we don't know what to do, we should recognize the word perimeter. So I know P equals side 1 plus side 2 plus side 3 plus side 4. I have to add up all of my sides. Now, because it's a parallelogram, you could have written this a different way, right? You could have written this as P equals 2 times, call it side 1, plus 2 times side 2, because opposite sides are parallel. So even though they're not labeled, this side is still x minus 10, and this side is still x plus 20. Right, so we just have to keep that in mind, right? So I could double the one side, double the other side, add them together. That would also work. Either way you choose to do it is up to you, but you should still get the same answer. So let's plug in our values. So p equals 2, side 1 will be x plus 20, or it could be x minus 10, doesn't really matter. And 2 times x minus 10. Okay, I have brackets, distributive property. I want to go through and expand, or distribute, or multiply. 2 times x is 2x. 2 times 20 is 40. Plus 2 times x is 2x. And 2 times negative 10 is negative 20. I have like terms, so I can collect like terms. P equals 4x plus 20. So all I've done is calculated the perimeter, I've simplified my expression, and I have p equals 4x plus 20. However, the question says, find the dimensions of her garden. So I need to somehow find out what x is. I have two variables, p and x. In order to solve for x, which I need to use to find the dimensions, I need to plug in something for p. And it does work out that I am told that the perimeter is equal to 100. So that comes right from the question. So that means that I can replace p with 100. So 100 equals 4x plus 20. I have a two-step equation. Cancel out the non-variable term. Balance it out. 80 equals 4x. Divide both sides by 4. One side cancels out. And I'm left with x equals 20. Am I done? Nope, I am not. And again, that goes back to the importance of highlighting the question. The question said, find the dimensions of her garden. X isn't a dimension. X is just what the variable equals. If I want the dimensions, I have to go back and say, okay, so x minus 10, instead of x, it is 20. So 20 minus 10 equals 10. So that means my one dimension is 10 meters. My other dimension, x plus 20. Instead of x, it's 20. So 20 plus 20 equals 40. So that means my other dimension is 40. So in this case, the dimensions are 10 and 40. Now I'm done. Now I found the dimensions of our garden. I answered the question. I'm done. So the main thing from this, none of the equations or the types of equations are new. Some of them might be given to us. Some of them we might have to determine on our own. But either way, once we do, they should be in a format where we can go through and solve. If not, we might have to plug in values for our variables, right? Which was where the highlighting of the question is very important. That comes into play because that will tell us what we can plug in, what we can replace, and then that should allow us to go through and then solve our equations. Right? So if you're struggling with some of the equations, make sure you go back and review some of the previous lessons so you can look at how to solve equations without any scenarios or word problems, just straightforward equations.